Hello there and welcome to Just About Earth, a place where curiosity settles in softly and the world around us becomes something you can ease into without rushing. Tonight's slow drifting thought is wrapped in frost and quiet, the kind of quiet that feels older than memory. We're sinking gently into an idea that has hovered at the edge of scientific debates and whispered through countless stories. It's the question of whether the deep layers of Ice Age remnants might be holding traces of something we haven't fully imagined yet, something that might change how we picture ourselves. The thought that a civilization could have risen long before the ones we usually talk about and disappeared beneath the cold without leaving the sort of signs we expect feels strange at first. But strangeness has a way of settling into place once you let your mind relax into it. Before we explore any of it, I'd love to know where you're listening from tonight and what the weather feels like around you. Maybe you're wrapped up in blankets or letting the quiet settle in as evening stretches on. If this wandering journey helps you unwind, it would mean a lot if you gave the video a like or subscribed so this little corner of calm can find others who might need it. Let's drift slowly now into the thought we're following, letting the pace ease down until the noise of the day falls away. When people imagine ice, they usually picture something smooth and empty, like a frozen sheet that leaves no room for much else. But the cold has a different personality when you give it time. Ice accumulates slowly, layer by layer, holding onto particles swept in from storms, volcanic dust, ancient pollen, broken fragments of stories left behind by the world as it shifts. These layers can stack over tens of thousands of years, building up like pages in an encyclopedia nobody expected to find. Each layer carries a record of the temperature, the air, the debris, the life, and the stillness of the year it grew over. And when scientists drill down into those frozen cores, they're reading time without flipping through it. They're unravelling long spans of Earth's memory, one subtle clue at a time. Among those clues, some people wonder whether there might be things that don't quite belong, things that hint at a moment in human history we haven't documented, a moment when people might have built something real and organised before the ice swept over them. Most of the time, we assume civilization is something that belongs to warm climates, to regions where crops could grow easily and rivers could flow without freezing for months. It makes sense. Agriculture thrives in warmth. Cities rise in places where the seasons are gentle enough for stored food to last and resources to move from one group to another. But the more we learn about early humans, the more adaptable they appear. They crossed continents in harsh conditions, built tools far earlier than anyone predicted, shaped environments even when they were moving constantly, and survived cold that would shut down most modern cities in a matter of days. It doesn't prove that they built large civilizations before the ice receded, but it does make the idea less far-fetched than it once seemed. When you begin with small questions like how far people travelled or what they gathered, the larger questions begin to feel less intimidating. One of those is whether some group, somewhere, constructed more than temporary shelters long before the structures we usually talk about. If they did, the ice would have been merciless. Buildings collapse, tools erode, trails vanish, and over tens of thousands of years the weight of the cold presses everything deeper, grinding it, shifting it, burying it under new layers that tell new stories. The quiet weight beneath the ice is not just a physical pressure but also a kind of silence that history can fall into when the evidence becomes too thin. Many of the oldest human-made sites in the world sit along coastlines, places that were dry land before the oceans rose after the last glacial period. Entire regions that once stretched far beyond modern shores are underwater now. During the Ice Age, sea levels were lower by more than 100 metres, which means the edges of continents were wider, offering space for habitation and perhaps even settlement. If any early society had taken root near those shorelines, most of its remains would now sit beneath cold, dark water, where currents erase fragile traces, and that's only the oceanic part of the puzzle. On land, glaciers behaved like slow-motion bulldozers, grinding rock and soil, shifting valley floors, depositing material hundreds of miles away. Anything left on the surface stood little chance of remaining in recognizable form. It becomes a challenge, not of imagination, but of preservation. What could survive that kind of pressure? What could remain intact under tens of thousands of years of shifting weight? When researchers drill into ancient ice, they find everything from soot to small meteor fragments to microorganisms still holding faint evidence of their past activity. Sometimes they find unexpected particles that don't have a clear explanation, at least not right away. These aren't artifacts in any ordinary sense. They aren't tools or carvings or anything shaped by hands. They're anomalies in the chemical or particulate record, signals that raise questions rather than answer them. Most are explained by natural processes once enough data is gathered, but a few lean closer to the margins of what we currently understand. The temptation is to fill those margins with stories about forgotten civilizations. The cautious voice in science asks for more evidence, more detail, more clarity. Between those two is the softer voice that wonders, without insisting whether we're overlooking something by assuming that complex societies must fit the patterns we already know. That quieter thought is the one we're following here, not to claim certainty, but to explore possibility. Imagine someone standing on a landscape that looks nothing like the one we know today. The air is colder. The horizon is lined with ice sheets that stretch farther than the eye can see. But at the edges of those sheets there are regions where the climate is cold but still manageable. Places with rivers fed by glacial melt, valleys where animals migrate, and coastlines that reach into lands now underwater. In those transitional zones, people could have gathered in larger numbers than we assume. They may have built structures from materials that degrade quickly, like wood, hides, or woven plant fibers. They may have shaped stones in ways that didn't last once glaciers pushed through, or once meltwater carried debris elsewhere. And if they reached a level of sophistication that involved extensive knowledge of seasons, hunting patterns, or even early forms of trade, those developments might leave little trace after so many cycles of freezing and thawing. Civilization doesn't have to mean skyscrapers or metalworking. It could simply mean organization, cooperation, shared knowledge, and continuity of behavior over multiple generations. Something like that could have existed long before the warm periods we usually examine. What makes the idea interesting isn't just whether such a civilization existed, but how we would recognize it now. Finding evidence beneath ice is significantly harder than finding it in deserts or temperate soil. Ice moves, it cracks, it melts and refreezes, it drifts over time, causing older layers to fold, twist or sink. The clues that remain may appear as tiny out-of-place chemical signatures, unexpected concentrations of certain minerals, or shifts in sediment patterns that don't match known climate events. These kinds of hints are subtle, easy to misinterpret, and even easier to dismiss. Yet they're the pieces scientists often return to when they notice trends in the data that don't neatly align with expected natural processes. These aren't conclusions, they're starting points, the scientific version of noticing a faint line on a map and wondering whether it once marked a forgotten road. There's also the matter of human memory, something that tends to last longer through stories than through physical remains. Many ancient cultures speak about times when great cold swept over lands or when earlier peoples were lost beneath the weight of snow and darkness. These accounts aren't proof, and they shouldn't be treated as such, but they offer a reminder that humans often encode experience in narrative when physical evidence doesn't survive. For most of history, stories travelled farther than artifacts. They moved with migrating groups, evolving as they passed through generations. Sometimes they stretched events, sometimes they blended memories with imagination. Even so, they often preserve the general outline of something that mattered deeply to the people who told them. When stories from different regions mention a period before known civilizations when earlier groups built or learned things that were later forgotten, it raises the question of whether these tales contain a faint echo of genuine past experiences. Another thing worth considering is how limited our view is when we look at the past. Archaeology is shaped not only by what is discovered, but by what can be discovered. Most of Earth's surface is difficult to search thoroughly. Some areas are too deep underwater, some are covered by dense forests, some sit beneath cities, and some are locked under glaciers. For every ancient structure or artifact found, countless others could lie in places we haven't surveyed. Many early structures discovered in the last century were initially overlooked because they didn't match the expectations archaeologists held at the time. Only after new methods developed, like satellite imaging or improved dating techniques, did researchers realize they were looking at something significant. If we apply that same humility to the Ice Age, it's reasonable to consider that the remains of an early civilization, if it existed, might be so deeply buried or degraded that only fragments of indirect evidence remain. The weight of ice doesn't simply crush what lies beneath, it also protects. Under the right circumstances, ice can preserve organic materials that would decay rapidly in warmer climates. It can freeze moments in place so completely that thousands of years pass without significant change. In some regions, the melting of long-held ice is revealing plants that look as though they were tucked away for a single season instead of millennia. If structures or tools somehow ended up in pockets with stable conditions, they might still exist in some altered form, waiting for the right moment to be uncovered. The challenge is knowing where to look and how deep to go. Ice cores give us vertical slices of time, but they don't reveal everything. Large areas remain untouched simply because drilling into them is difficult, expensive, and time-consuming. Even then, the cores retrieved are narrow, offering glimpses rather than full pictures. One thing that keeps this possibility alive is how often new discoveries rewrite assumptions about early human behaviour. Finds that were once considered impossible have become accepted over time as more evidence emerges. People living in regions previously thought uninhabitable, tools older than expected, art created long before symbolic thinking was believed to have developed. These adjustments don't prove that there was a forgotten civilization beneath Ice Age layers, but they do remind us that human history is more flexible than it seems. The timeline shifts whenever new information comes to light. The idea of an earlier organised society may feel unconventional now, but unconventional ideas often become ordinary once the right data arrives. Thinking about the quiet weight beneath the ice is not about creating dramatic claims. It's about recognising the gaps in our knowledge and allowing curiosity to explore them without forcing conclusions. The ice holds a record of climate, atmosphere, and geological events that shaped the planet long before humans studied them. Within that record might be faint impressions of human activity that doesn't fit the patterns we anticipate. If such impressions exist, they won't announce themselves loudly. They'll sit in the margins, waiting for someone patient enough to notice the subtle ways they differ from natural processes. When the cold settled across the world in ways it hadn't before and hasn't since, the shift wasn't something that happened in a single moment. It built slowly, settling into place the way night replaces day, when the sky darkens so gradually that you barely notice the change until it's already complete. The world entered a long period where ice didn't simply exist at the poles or cling to mountaintops. It grew outward, covering entire regions, pushing into landscapes that had once been lively and warm. The quiet that followed wasn't just the absence of heat. It was the absence of ordinary rhythms, the slowing of patterns that life had relied on. Rivers moved more sluggishly. Forests shrank. Animals found themselves confined to smaller pockets where they could survive. And humans, scattered and resourceful, had to navigate a planet shifting around them in ways they couldn't fully understand. The ancient world didn't freeze overnight, but over the generations the cold became the defining shape of their surroundings, creating conditions that would eventually hide not only land, but any traces of the stories unfolding on it. When people today picture an ice age, they often imagine a world locked in unbroken white, but the truth was more complicated. There were places where the cold was harsh and relentless, Yet there were also regions where life continued in valleys, along coastlines and near rivers fed by meltwater. These areas were still frigid, but they offered enough stability for plants, animals, and people to persist. Even so, the global shift toward colder temperatures changed everything. Animals that roamed freely across wide grasslands found their paths narrowed. Forests that had stretched across continents retreated. Entire ecosystems rearranged themselves. And in the middle of this transformation, humans adapted by finding new ways to survive, new routes to follow, and new strategies to handle the scarcity around them. Every adjustment became part of a long, quiet negotiation with the climate, one that required constant awareness of the shifting world. Much of human activity during those colder eras left subtle marks. Instead of sprawling cities or carved stone monuments, there were temporary shelters built from what people could find quickly, structures that wouldn't last long in the face of advancing ice. People created tools suited for hunting in harsh conditions, crafted clothing from thick hides, and learned to move regularly to stay near food sources. These weren't the kinds of developments that would survive the grinding force of glaciers. They weren't built to endure millennia of pressure, frozen weight, and shifting debris. And yet, even in these quiet adaptations, there were hints of organisation and shared knowledge that could, under slightly different circumstances, have grown into something larger. That possibility lingers whenever researchers study the remnants of early human groups, because the line between survival strategies and early forms of civilization isn't always as clear as it seems. The world that froze didn't do so evenly. Parts of the planet remained warm enough to sustain life comfortably, while others endured prolonged cold that reshaped the land. In areas closest to the growing ice sheets, the landscape changed rapidly compared to the slower, more gradual shifts elsewhere. When glaciers expanded, they carved out valleys, smoothed mountainsides, and pushed soil and rock across vast distances. Anything sitting on the surface, structures, pathways, objects, stood little chance of remaining undisturbed. The ice wasn't gentle, it pressed forward with tremendous force, dragging along the ground beneath it, breaking apart whatever it encountered, and eventually burying the fragments deep within layers of compacted snow that hardened into ice over time. If there had been a settlement in the path of such a glacier, its ruins would be indistinguishable now from the rocks ground into powder beneath that weight. These massive ice sheets didn't only alter the land they touched, they also influenced regions far beyond their immediate reach. Global climate patterns shifted, oceans cooled, winds carried new combinations of dust, salt, pollen, and ash. The world's chemistry changed a little each year in ways that researchers can still trace through ice cores. When you look at those cores, you see a record of quiet changes accumulating over thousands of years. Volcanic eruptions leave thin layers of distinct particles. Changes in the atmosphere show up as variations in trapped gas bubbles. Even distant forest fires send their signature into the ice, preserved long after the trees that burned have vanished. The layers become a kind of diary, written slowly and without intention, documenting the world as it moved deeper into cold. At the same time, the oceans responded to the increased amount of water locked in ice. Sea levels dropped dramatically, exposing land that is now completely underwater. These coastal plains were not barren stretches, but thriving environments where fresh water mixed with salt water, creating ecosystems rich in plants and animals. Many researchers believe humans lived in these regions in significant numbers. They were, after all, perfect for settlement: ample food, access to water, and relatively moderate temperatures. But when the ice began to retreat thousands of years later, and sea levels rose again, these lands disappeared beneath the waves. If people had built anything there, very little would remain now. Organic materials rot quickly underwater. Stone structures collapse. Sediment buries everything. Archaeologists can only study a limited portion of these submerged landscapes, and even with modern technology, exploration is difficult. It's entirely possible that sprawling areas containing early forms of human organisation were swallowed by the ocean, before anyone could record them. As the Ice Age deepened, humans living on the exposed land had to confront new challenges. They followed migrating animals, adapted to harsher winters, and found ways to store food that would last during extended cold periods. Some groups used caves for shelter, leaving behind artwork or tools that survived because they were protected from the weather. Others built temporary structures near rivers or coastlines, which were carried away by floods or crushed under shifting ice. The silence that fell over much of prehistory wasn't due to a lack of activity, but due to a lack of surviving evidence. Glaciers don't leave behind clean, accessible layers of the past. They bury and distort, grind and scatter, creating a geological puzzle that's incredibly difficult to piece together. Still, the idea that humans were present in large numbers during these colder eras isn't speculative. There are well-documented sites showing advanced hunting strategies. There are tools appearing earlier than expected. There are bones with cut marks indicating organised butchery. And there are signs of long-distance movements suggesting communication among groups separated by large regions. These are all characteristics of behaviour that could form the foundation of a more complex society, even if that society never reached the structural sophistication we associate with later civilizations. The quiet world of the Ice Age was not empty. It was filled with people who were observant, skilled, and capable of innovation. If any of these early humans developed forms of organisation or knowledge sharing that went beyond what we typically imagine, the frozen world around them would have been both a challenge and a form of concealment. Cold climates preserve some materials exceptionally well, but only if those materials remain undisturbed. Once a glacier moves across them, preservation becomes almost impossible. While ice can protect artifacts under certain conditions, glacial movement destroys far more than it safeguards. That destructive pressure is one reason why researchers rarely find complex structures from extremely cold periods. It's not necessarily because none existed. It may simply be because the ice was too thorough in reshaping the land. Another reason the record feels silent is that ancient humans placed value on mobility. Staying in one place too long wasn't always practical. They followed caribou herds, fish migrations, and seasonal plant growth. They built shelters meant to be used for short periods before moving on. These patterns don't leave behind the sort of permanent marks that large civilizations would later create. But mobility doesn't equate to simplicity. People could have passed down knowledge through generations, developed intricate hunting strategies, shared stories that carried information about survival, and even traded materials across large distances. These practices could enrich a community's understanding of the world, helping them thrive in conditions far harsher than any modern society faces today. The world's frozen silence also created gaps in our understanding of technological progression. Tools that appear suddenly advanced might not be sudden at all. They could be the result of long, slow learning processes carried out by earlier groups whose innovations were lost under ice, water, or shifting sediment. When a technological leap seems abrupt in the archaeological record, it often indicates a missing piece of the timeline rather than an overnight discovery. The Ice Age created many of these missing pieces, erasing or burying evidence that might have revealed the steps by which early humans built knowledge. Even the way landscapes changed contributed to the loss of information. Regions that were once fertile terraces are now valleys filled with glacial debris. Areas that supported animals and people alike turned into barren stretches after glaciers receded. Soil layers mixed. Sediment accumulated quickly. Rivers carved new paths as meltwater surged through freshly exposed terrain. Each alteration removed context from whatever objects might still lie hidden. Without context, interpretation becomes guesswork, and the story of early human activity becomes blurred. The silence that settled over history during the coldest periods wasn't the absence of life or creativity. It was the effect of powerful natural forces burying the details beneath layers that are difficult to read. The deeper researchers look, the clearer it becomes that humans were present long before the warm, stable climates in which later civilizations developed. They adapted, learned and persisted even as ice dominated much of the world. If they had reached a stage of early social organisation, the world that froze around them would have erased most of the physical traces. But the patterns of survival they left behind suggest that the possibility isn't as unlikely as once assumed. When people talk about the past, they usually imagine written records, carved symbols, pottery, tools, or buildings standing long enough for someone far in the future to notice. But the Earth keeps its own accounts in ways that aren't always obvious to us. Ice, soil, sediment, and even windblown dust become layers that settle into quiet archives, holding traces of events far older than anything humans have written down. These layers don't speak in clear sentences. They don't offer tidy explanations. They store fragments, tiny changes in chemistry, slight differences in texture, unusual patterns that hint at moments we would otherwise never know existed. When you walk across a snowy field, or look at a coastline where waves pull sand into shifting lines, it's easy to forget that the ground beneath your feet has a memory. The deeper you go into that memory, the less it resembles the world we live in now. And in those ancient depths, where cold has pressed everything into stillness, there are hints of activity that challenge the timelines we've built for ourselves. Ice cores pulled from Greenland, Antarctica, and glaciated mountain ranges slice through thousands of years of accumulation. Each thin sheet forms during a single season, trapping air bubbles, dust, soot, pollen, salts, and everything else drifting in the atmosphere at that time. Some layers are thick because the year was snowy. Others are thin because the year was dry or unusually cold. Each one becomes part of a vertical story you can read if you understand what the signals mean. Scientists have become skilled at interpreting these subtle clues, spotting the fingerprints of volcanic eruptions, forest fires, periods of drought, and shifts in ocean circulation. They can recognize the arrival of industrial pollution long before the notes left by those responsible began filling archives. But there are older signals that don't match natural patterns neatly. These fragments are where curiosity begins to expand because they raise a simple question: who or what created them? Most of the time, these unusual signals turn out to have natural explanations. A distant eruption, a sudden change in ocean chemistry, a rare dust event carried by unusual winds. But every so often the patterns cluster in ways that encourage researchers to look twice. The layers remember things that never made it into human memory. They record events that happened before writing, before agriculture, before we even settled into the rhythms we associate with early societies. And within those deep layers, far below the oldest confirmed settlements, there are signs of sudden changes in atmospheric composition that don't immediately fit known geological processes. These anomalies aren't clear enough to claim anything definitive, but they do create space for questions. Some suggest a moment of unexpected burning activity. Others indicate the rapid introduction of elements that appear rarely in that region's natural history. They could be natural, they might not be. The ambiguity is what makes them compelling. One of the most interesting things about these layers is how meticulously they preserve contrast. A year with heavy plant growth will differ in its chemical signature from one marked by widespread drought. A season of heavy animal migration leaves behind biological traces unlike those from a season of stillness. Humans, even in small numbers, affect the landscape in their own ways. When early groups burned wood to clear an area, or cooked food, or gathered around fires to stay warm, those actions would release particles into the air. Most of these signs would vanish quickly in open landscapes, but if the smoke drifted onto the growing snowpack at the edges of a freezing world, it could become trapped in the layers. That soot might settle far from where the original fire burned, carried by winds no one recorded, drifting until it met cold that captured it more faithfully than any tool could. This raises an important point about Ice Age memory. The layers don't care whether the particles they trap come from a natural fire or from human activity. They don't differentiate between the volcanic ash from a mountain eruption and the ash from a widespread burning event triggered by early people clearing space or processing food. In both cases, the particles become part of the snow and eventually compress into ice. If humans created fires repeatedly in the same region over many years, the layers would show consistent signals. If people gathered in larger numbers, producing more smoke than the environment normally generated, it would leave a stronger chemical trace. But the ice doesn't tell us who placed those materials into the air. It only tells us they were there. Looking deeper into these frozen archives, some researchers have noticed patterns of soot concentration that rise and fall in cycles not easily explained by known natural fires. These aren't definitive signs of human activity, but they do raise questions, especially when they appear in layers far older than any documented settlement. If early groups were more numerous or more organised during those times than previously believed, they might have produced more smoke than expected. Perhaps they used controlled burning to influence animal behaviour. Perhaps they cleared vegetation intentionally. Or perhaps they engaged in some activity we haven't yet imagined. Understanding these patterns requires comparing them with other climate records, geological evidence, and what we know about ancient ecosystems. Even then, the conclusions remain cautious because the signals are faint. There are other kinds of memory stored in these layers. Trapped air bubbles contain precise snapshots of ancient atmospheres. Researchers can measure the levels of carbon dioxide, methane, nitrogen, and other gases from thousands of years ago. Most variations follow natural patterns tied to ocean cycles, plant growth, and large-scale climate shifts. But a few periods show rapid changes that don't fit neatly into typical cycles. Again, these aren't direct evidence of human influence. They could be linked to unusual environmental events. But if people were more active during those times than currently assumed, even seemingly small contributions could create measurable fluctuations. The layers remember the atmosphere exactly as it was, without interpretation, leaving modern scientists to make sense of what the data implies. Sediment layers tell a related story. When lakes freeze repeatedly and receive layers of silt, pollen, and organic matter, they create a record similar to ice cores but with different strengths. Lake sediments can capture the arrival of new plant species, the disappearance of old ones, and the presence of unusual compounds. Some sediments contain evidence of tool use, such as microscopic wear patterns on mineral grains that appear when grinding or cutting takes place nearby. Others hold traces of pigments that suggest early forms of artwork or body decoration. These subtle clues don't confirm the existence of a lost civilization, but they do show that early humans were experimenting with techniques and materials far earlier than expected. The layers preserve these hints because sediment accumulation is gradual and consistent, providing a steady backdrop against which unusual signals stand out. Dust layers carried from distant regions present another intriguing form of memory. When dust travels long distances, it carries minerals that match the geography of its origin. By analysing the composition, scientists can determine where it came from and which conditions allowed it to move across continents. Some dust events recorded in ancient layers indicate climate patterns different from what models predicted. Others show sudden deposits of mineral mixtures that seem out of place. These could be the result of unusual storms, shifts in desert boundaries, or volcanic eruptions. But if human activity influenced vegetation coverage or soil stability in unexpected ways, it could also explain unusual dust movement. This isn't proof of early organised societies, but it does highlight how interconnected human activity can be with environmental signals, even when recorded in layers far older than the first confirmed cities. Beyond the physical clues, the layers also reflect time in ways human memory cannot. They document long transitions, the slow retreat of forests, the gradual cooling of regions, and the subtle shifts in ocean salinity driven by ice growth. These changes shape the world humans inhabited long before writing emerged. They reveal how landscapes supported migrations, how coastlines expanded during cold periods, and how massive stretches of land now lost beneath the sea once provided habitats rich in resources. If early people had lived along those coastlines, their activities would have contributed to the environmental signals recorded in ice and sediment. But the structures they built or the materials they used would now lie underwater, buried in places we rarely explore. Some layers contain microplastics or industrial pollutants from modern times, reminding us how easily the environment absorbs human activity. If today's traces can spread globally within decades, it's worth considering that smaller human contributions thousands of years ago might also have reached far beyond their origins. But because those contributions were smaller and the world was colder, their signals would be faint. The deeper the layers, the more compact and distorted they become. Interpreting those signals becomes harder because pressure changes their structure and mixing occurs over long timescales. Even so, certain anomalies persist, standing out as slight but detectable irregularities. A guiding question here is not whether early humans left behind monuments or advanced cities, but whether they left behind evidence of organisation, behaviour, and knowledge that we haven't connected to the archaeological record yet. The layers beneath the ice remember every variation, even if the meaning is unclear. They store the rhythm of a world shaped by cold, but populated by people who continue to adapt and interact with their surroundings. If those people reached levels of cooperation or innovation that we haven't yet attributed to their era, the ice would preserve only the faintest marks of it. These marks might appear as unusual soot deposits, unexpected mineral signatures, or atmospheric shifts. The deeper scientists look, the more they realise that the Earth itself has been keeping track of everything, even when the details escape us. Each preserved layer is a moment captured without intention, an unfiltered record of conditions that once existed. The world remembers more than humans do because it has no choice. It accumulates experience continuously, whether or not anyone is present to interpret it. If the Ice Age hid chapters of human development that haven't yet surfaced, the clues will be in these subtle variations rather than in recognisable structures. When researchers talk about footprints that don't quite fit the timelines we've built, the conversation usually begins with caution. A footprint is a fragile thing. It forms in soft ground, stays only if conditions align perfectly, and disappears easily if the weather changes or if animals wander over it. For a footprint to survive long enough to be discovered thousands or even tens of thousands of years later, an entire sequence of unlikely events has to work together. Mud has to dry in just the right way. Sediment has to settle over it gently. The ground has to remain stable. Water levels can't shift too dramatically. Larger animals can't trample it. Pressure from above must stay evenly distributed. It's the kind of preservation that doesn't happen often, which is why each footprint discovered from deep time feels like a message written in a language that barely survived. And when those messages don't match the stories we've been telling ourselves about early humans, they become even more interesting. Footprints older than expected have surfaced in several places over the last few decades, and each one brings with it a sense of quiet disruption. They don't shout. They don't reveal detailed histories. They simply offer a presence where no presence was supposed to be. Some footprints appear in layers long predating the commonly accepted timelines of human migration. Others appear in regions thought to have been uninhabited at the time. A few appear in sediment that was believed to be too unstable or too isolated to support early human activity. Each discovery prompts debate, not because the footprint itself is unclear, but because its age or location forces researchers to reconsider assumptions about where people could have been and what they were capable of during certain periods. Most of these footprints don't point to a lost civilization, at least not directly. They point to movement, to individuals or groups passing through landscapes we thought were empty. But movement itself carries meaning. A single set of footprints suggests a person travelling alone, yet footprints rarely come alone. Many discoveries include prints from children, adults, and sometimes animals moving alongside them. That implies social structure, shared travel, and cooperation. It suggests that people didn't simply wander randomly, but travelled with purpose. When footprints appear in places that would have been difficult to reach during Ice Age conditions, they raise the possibility that people had strategies, routes, and patterns of movement more complex than the archaeological record currently shows. One example that often comes up in these discussions is the series of footprints found in areas that were believed to be submerged or seasonally flooded during the period they were dated to. If the dating is accurate, people found ways to navigate those environments, perhaps using knowledge of tides, seasonal changes, or the behaviour of local animals to move safely across ground that appears inhospitable in modern reconstructions. These traces indicate competence and understanding, the sort of traits that emerge when groups pass down knowledge across generations. Even if this isn't civilization in the traditional sense, it points to a level of organisation that can feed into larger, more complex cultural developments. There are also footprints that appear in layers that don't align with our current migration models. One set might suggest that humans arrived in a region thousands of years earlier than expected. Another might point to repeated visits to a location once thought to be merely a transient path. When combined, these anomalies paint a quieter, more nuanced picture of early human activity, one that includes curiosity, exploration, and adaptability far beyond the limited view we often hold. Early humans may have followed coastlines, rivers, or animal migrations in patterns that repeated over centuries. And while most of their movement left no lasting trace, these rare preserved footprints serve as reminders that life was happening in places we hadn't accounted for. Some footprints discovered in colder regions complicate the picture even further. These impressions show people walking across landscapes close to the edges of expanding glaciers, possibly following herds or seeking new resources. What makes these particular finds intriguing is not just their survival, but their placement. People weren't merely surviving on the fringes of an Ice Age world. They were moving through it, exploring it, and possibly adapting to it in dynamic ways. If they understood the behaviour of glaciers, meltwater, or the animals living near the ice, they might have developed routes that connected regions we once believed isolated. These pathways could have facilitated communication or exchange long before clear archaeological evidence of such networks appears. Footprints also reveal details about gait, speed, and sometimes even the condition of the walker. A dragging toe mark might suggest someone carrying a heavy load. A wide stride might indicate someone running. Sets of prints close together can suggest group cohesion, while overlapping prints indicate frequent travel along the same path. When researchers find multiple layers of footprints in the same area, it implies repeated use over long periods. That alone hints at knowledge of the landscape passed from one generation to the next. And any form of knowledge transmission, no matter how simple it may seem, sits at the heart of community structure. In some cases, footprints appear alongside marks that aren't quite footprints, but also aren't random impressions. These might be tool marks, drag marks from carrying something, or depressions created by sitting or kneeling. Such traces are harder to interpret, but they suggest activity beyond mere travel. They hint at moments of rest, tool use, or perhaps preparation of materials. When these marks show up deep in Ice Age layers, they add another thread to the tapestry of human activity during periods we typically imagine as sparsely populated. The landscape wasn't empty. It was used, shaped, and traversed by people who had a clear understanding of their needs and how to meet them. Some footprints challenge assumptions because of their size or depth. A deeper print might suggest someone carrying significant weight or walking on soft ground. Larger prints have at times been misidentified as belonging to early humans when they were actually animal tracks distorted by melting or compression. Still, a few remain stubbornly ambiguous. Careful analysis usually provides an explanation, but the process itself highlights how delicate and open-ended these discoveries can be. A single footprint can create years of debate, new studies, and adjustments to migration models. That's the power of a trace left unintentionally by someone who never imagined it would last longer than the next rainfall. The most compelling part of these finds isn't the individual prints, but how they accumulate into a broader pattern. Each discovery that doesn't fit the standard timeline or expected route becomes a piece of a puzzle. Taken individually, they're anomalies. Taken together, they imply that our view of early human movement is incomplete. People may have travelled earlier, farther, or through more challenging environments than previously believed. And when movement is broader than expected, the possibility of early pockets of settled or semi-settled groups becomes more plausible. A footprint doesn't prove such a group existed, but it shows that humans were present in places where we didn't think they were, and presence is the first requirement for any form of community to grow. There's also the matter of how footprints intersect with stories passed down through oral traditions. Many cultures have legends about ancestors who travelled across frozen landscapes, crossed great distances, or lived in places that later became uninhabitable. These stories often include references to paths through ice, gatherings near glacial edges, or migrations prompted by environmental change. Oral traditions can stretch back thousands of years, and while details shift over time, the overall themes sometimes align with what the geological record suggests. Footprints in unexpected layers give weight to the possibility that these stories preserve echoes of real events that happened long before they were written down. When footprints appear in areas that later became covered by ice, it's natural to wonder what else was present before the glaciers moved through. Prints alone cannot reveal the full picture, but they indicate a level of familiarity with the environment that could support more complex activities. If people were active in those regions for extended periods, they may have developed small sites for working on tools, preparing food, or gathering materials. These sites would likely have been destroyed by advancing ice, leaving only the faintest clues in the layers beneath. Footprints serve as a reminder that even when the material evidence is gone, the traces of life can remain in forms we rarely expect. Interpreting these enigmatic traces requires patience. Each new footprint discovery teaches researchers to look more closely at layers once dismissed as irrelevant, or too disturbed to contain useful information. It encourages a broader perspective on where early humans might have lived and how they might have travelled. The idea that people were active in areas not traditionally included in migration models suggests a flexibility and resilience that isn't always reflected in our narratives about the past. The presence of footprints that seem to appear before they should doesn't rewrite history on its own. Instead, it widens the space in which questions can be asked. If early humans were capable of reaching and surviving in these locations, what else might they have done? What knowledge did they carry about weather patterns, animal behaviour, or seasonal shifts? What tools did they use that left no trace? The prints bring us close enough to feel the presence of the individuals who made them, but distant enough to keep their full story out of reach. Warm periods come and go in Earth's long climate cycles, but the ones that occurred during and between the great glacial advances often slip out of focus when we talk about early human history. These interludes were not brief flickers of mild weather. They were stretches of time long enough for landscapes to bloom, for coastlines to stretch far beyond their present boundaries, and for entire ecosystems to settle into stability before sinking once more beneath advancing cold. Thinking about these warm ages changes the way we picture the past because they open gaps in the timeline where people could have lived in regions now hidden underwater or buried beneath later layers of ice. When we look at the world today, we see coastlines as fixed and climates as relatively stable. But these assumptions don't apply to the world early humans inhabited. Instead, they lived through transformations so large that the Earth we know now would have felt like a distant idea to them. During these warmer intervals, sea levels dropped dramatically because so much water remained locked in ice sheets further north. This created vast stretches of land where oceans now cover the seafloor. Those regions weren't barren. They supported forests, grasslands, freshwater wetlands, and coastlines that offered abundant food. Herds of animals migrated across them. Rivers carved paths through them. People likely travelled through these regions with regularity, following seasonal patterns that later became inaccessible once the interglacial warmth faded. When the cold returned and glaciers began expanding again, these landscapes shrank or vanished altogether. Rising seas swallowed entire coastlines, leaving no trace of whatever was built or used there. What remained was buried or dispersed by currents, sediment and time. Many researchers suspect that these submerged regions hold clues to early human activity that are extremely difficult to recover today. Evidence found on present-day coastlines suggests people were remarkably adaptive and capable of exploiting marine resources far earlier than once believed. Shell middens, tools made from bone and stone, and fishing implements all point to a familiarity with coastal environments that would have extended naturally into the now vanished plains lying offshore. If families or larger groups settled along those former shorelines, they would have created temporary shelters or more durable structures that later succumbed to rising seas. Once underwater, organic materials decayed quickly, while inorganic ones became hidden under layers of sediment. The disappearance of these landscapes means that a significant portion of early human history now sits beyond easy reach. Some underwater discoveries hint at this missing record. Divers and sonar surveys have located ancient river channels on the seabed, suggesting that these areas once teemed with life. They also reveal hills and ridges where people could have camped, hunted, or gathered resources. In a few places, stone tools have been recovered from depth that correspond to periods when sea levels were much lower. These finds don't show full settlements, but they prove that humans lived in areas now submerged. They also raise the possibility that much more remains undiscovered. If early groups built communities along these shores, those structures would have been lost as the oceans rose. The few sites found so far are likely only fragments from much larger regions now sealed beneath water. Warm periods didn't only create new land, they also allowed vegetation to flourish across areas that today seem inhospitable. Regions now marked by tundra or glacial formations once supported forests and meadows where animal populations expanded. With abundant resources, early groups could gather in larger numbers, forming communities that stayed in one place for longer stretches of time. These gatherings might not have left the type of archaeological footprints we expect from later civilizations, but they would have nurtured cooperation, shared knowledge, and innovation. People learned to track seasons, predict animal migrations, and make tools suited to a changing environment. Over generations, these skills could have formed the basis for more complex social structures. When the climate cooled again, much of this activity disappeared beneath advancing snow and ice. Forests became buried, rivers froze or shifted course. Plants that once thrived were replaced by cold-resistant species. Entire regions became inaccessible as glaciers carved their way across the landscape. Whatever remained on the surface would have been crushed, moved, or ground down. Even stone features could be shattered or transported far from their original locations. The layers we see today, whether ice or sediment, preserve only small glimpses of what happened before the cold returned. For every site that survives, countless others were erased. Understanding these warm ages requires looking beyond a simple linear narrative of human development. Instead of imagining a smooth, continuous rise from simple groups to complex societies, the evidence suggests something more uneven. Periods of mild climate might have supported growth, innovation, and organization. Then cold periods could have erased nearly all physical traces of that progress, forcing people to adapt once more to a harsher world. This cycle might have repeated several times. The possibility that early groups reached a higher level of organization during these warm intervals becomes more reasonable when considering how much of the archaeological record is missing due to climate shifts. Some studies of ancient climate layers reveal abrupt transitions, sharp warming events followed by gradual cooling phases. These changes affected rainfall patterns, plant growth, and animal populations. In regions where warmth returned suddenly, early humans would have experienced rapid ecological opportunities. Rivers that had been frozen became flowing sources of fresh water. Valleys once covered by ice turned into fertile grounds. Lakes expanded, drawing in animals and creating new resource-rich zones. These changes would have influenced human behaviour significantly. Groups who lived through these transitions would have needed flexible strategies, keen awareness of their surroundings, and the ability to share knowledge quickly. When warmth faded and glaciers advanced again, those strategies would have shifted. Communities that once thrived along expansive coastlines might have moved inland, following rivers or migrating animals. The shrinking availability of resources could have forced groups to split up, travel further, or adapt new hunting and gathering techniques. These responses demonstrate resilience, not stagnation. They also point to the likelihood that knowledge persisted even when structures and artifacts did not. A people capable of adapting to these significant environmental shifts would not simply disappear without leaving some trace of their abilities in the landscape or the layers beneath it. The vanished shores from these warm ages hold a particular importance because coastlines tend to be hubs for human activity. Access to marine life, fresh water, flat land and mild temperatures creates ideal conditions for groups to settle for extended periods. If early humans did form organised communities or early social networks, these locations would have been prime candidates. The subsequent flooding of these regions means we now have only partial insight into what happened there. Underwater archaeology is difficult, limited, and expensive. Only small portions of these submerged areas have been examined. Most remain untouched, leaving vast portions of early human history hidden. Even in shallow waters, recovery of artifacts requires careful excavation, controlled dredging, and protection from strong currents. One wrong movement can disturb fragile materials, scattering them or causing them to dissolve. Stone tools survive better than organic materials, but even they can become heavily eroded. Considering these challenges, it becomes easier to understand how entire communities could vanish without leaving behind a recognizable footprint. Warm ages provided opportunities for growth that did not align with the limited geography we can easily access today. The best evidence for these lost landscapes remains locked underwater or buried beneath glacial debris. Another aspect worth considering is that warm ages likely influenced not only where people lived, but how they lived. Abundant resources allow time for experimentation. People may have tested new building methods, created early forms of storage, or experimented with artistic expression. These developments, happening far earlier than traditional timelines suggest, might have faded during the return of colder conditions, leaving only distant echoes in later traditions or in fragments preserved in sheltered spaces. Warm climates also allow greater interaction among groups. As animals migrated across newly accessible plains, human groups might have crossed paths more often, sharing knowledge, trading materials, or forming relationships that stretched across regions. These interactions could have shaped cultural development in ways no longer visible. Some modern researchers speculate that early humans may have had established networks along these now vanished coasts, moving goods and ideas across distances greater than once assumed. This idea isn't based on elaborate structures but on patterns found in scattered tools, pigments, and materials from different regions. Similarities in tool-making techniques across wide geographic areas hint at shared knowledge or contact. These similarities might have developed naturally, but they also might point to early forms of communication or exchange. When the warm periods ended, these networks could have collapsed or shifted inland, leaving only subtle, hard-to-interpret remnants. The puzzle becomes more complicated when considering how rising seas altered not only the physical world but the archaeological record. As coastlines retreated inland, erosion reshaped the landscape. Shorelines that once held campsites or working areas became underwater ledges. Any tools or remains left behind were either buried by sediment or swept away. Over time, marine life colonized these areas, further altering the material traces. Even when divers locate promising sites, distinguishing human-made structures from natural formations becomes a challenge. The older the site, the more ambiguous the evidence becomes. All of this means that the warm ages created opportunities for human complexity that may not appear in surviving artifacts. The erased coastlines complicate our understanding of where early people lived, how they organised themselves, and what they accomplished. When we say evidence is lacking, it may be more accurate to say that evidence has been thoroughly hidden. The Earth does not preserve everything in equal measure. The warmer climates gifted early humans the chance to flourish, while the colder climates took away much of the record of whatever they built. Civilizations don't always emerge in the conditions we assume are necessary. When we picture the rise of a society, we tend to imagine stable climates, reliable food sources, growing populations and long-term settlements. Yet the deeper we look into prehistory, the more it becomes clear that humans have been capable of coordinated effort, shared knowledge, and structured life far earlier than traditional timelines suggest. The world, during the long stretches of cold and the brief intermissions of warmth, was not an easy place to settle into routines. Even so, people found ways to build patterns within the unpredictability. Once those patterns form and persist across generations, something resembling civilization can begin to take shape, even if it doesn't resemble the stone cities or agricultural networks we usually associate with that word. A society doesn't need monumental architecture or written language to qualify as complex. It only needs layers of shared understanding, routines passed down through generations, cooperative structures, and a way of organizing resources that moves beyond simple survival. Early humans demonstrated these capabilities in many ways. Their long migrations required planning, coordination, and memory. Their hunting methods relied on strategy rather than chance. Their tool-making involved skill learned from others, refined over time, and adapted to shifting conditions. These traits grow naturally into more intricate forms of organization whenever groups gather in one place long enough to build traditions. Patterns of cooperation were already evident in small communities moving through Ice Age landscapes. Families relied on one another for hunting, gathering, and childcare. Groups coordinated seasonal movements and responded collectively to environmental changes. These are not simple tasks. They require communication, social stability, knowledge transfer, and shared purpose. The seeds of civilization don't start with cities. They start with people depending on one another, remembering what worked, and passing down techniques that make life easier for the next generation. If a warm period created a stable environment, even briefly, early groups may have taken advantage of that newfound consistency. Food availability increases when forests and grasslands expand. Rivers become predictable sources of fish. Plants grow more reliably. These conditions encourage groups to stay in one area longer, gradually shifting from constant movement to seasonal or semi-permanent living. Once people return to the same place year after year, structures emerge: physical, social, and cultural. Temporary shelters might become more elaborate. Hearths could be reinforced or rebuilt. Spaces for storage might appear. Over time, these adjustments accumulate, forming systems that resemble early settlement patterns. Even a handful of stable generations in one place can cultivate traditions that continue long after the environment changes again. The problem is that the physical traces of those traditions rarely survive glacial cycles. Ice and shifting coastlines eliminate nearly all remains except for the most durable objects, and even those scatter easily. If early groups built primarily with wood, plant fibers, hides, or earth, the evidence would have vanished. What remains today would be indirect: unusual concentrations of soot, signs of repeated burning, clusters of tools, or sediment patterns hinting at long-term presence. Early societies could also develop complexity through specialized roles, even if those roles weren't as rigid as those found in later civilizations. Some members of the group might have been more skilled at crafting particular types of tools. Others might have been responsible for tracking seasonal changes. Some may have worked as navigators, storytellers, or healers. These roles grow naturally from the needs of the group, especially when challenges demand solutions beyond simple instinct. when individuals follow specific responsibilities and pass on their knowledge. The group becomes more organized, structured, and capable of sustained growth. Warm climates offer the stability necessary for role specialization. If food is abundant, not everyone must participate in hunting or gathering all the time. People can devote energy to creating better tools, experimenting with new materials, or developing early forms of art or symbolic communication. These activities leave minimal traces, but their existence suggests a level of social sophistication. When roles diversify and knowledge spreads between groups, networks begin to form. A network doesn't have to be vast to be meaningful. Even small-scale exchanges of materials between neighbouring groups can indicate a connected system. Another ingredient for early civilization is the development of memory beyond individual experience. Storytelling provides this function naturally. Long before writing emerged, stories preserved knowledge, taught lessons, and maintained continuity between generations. They explained animal behaviour, reviewed past hardships, identified important locations, and mapped seasonal cycles. When stories become shared across larger communities, they create cultural cohesion. A civilization can form around shared beliefs, practices, and traditions, even if the environment is challenging and the population is scattered. The idea of before the world was ready isn't about the literal readiness of the planet, but about our assumptions concerning when complexity should appear. Modern frameworks often tie the rise of civilization to agriculture or permanent architecture. But humans were capable of cooperation and cultural development long before they grew crops or shaped stone into cities. If early groups achieved forms of organization that fit their environment, those developments deserve recognition, even if they don't match the visible markers historians rely on. A civilization adapted to the conditions of the Ice Age would not look like Sumer, Egypt, or the Indus Valley. It would be smaller, more flexible, and more deeply attuned to seasonal changes. But it would still be a civilization. The possibility that such groups existed becomes more plausible when examining scattered archaeological anomalies. In some regions, tools appear far more advanced than expected for their era. In others, pigments and decorations suggest symbolic thinking that predates known settlements. Remains of large animal hunting scenes reveal coordinated group strategies requiring planning and communication. These fragments hint at social structures that could support larger and more sophisticated networks. Migration itself can be a sign of organized society. Moving across long distances repeatedly, following paths that require knowledge of geography, implies that groups shared information about routes, dangers, and resources. This kind of collective navigation is not simple. It requires maps held in memory, signals encoded in stories, and leadership roles that guide the group through unfamiliar terrain. A civilization that moves is no less significant than one that stays in one place. Mobility simply leaves fewer physical reminders. Some researchers have suggested that early humans may have practiced forms of proto-agriculture long before the commonly accepted dates. This might involve managing wild plant growth, encouraging certain species to spread, or returning to specific areas where plants thrived after controlled burning. These techniques don't require domestication of crops, but demonstrate environmental manipulation associated with growing cultural complexity. If practiced consistently during warm intervals, such knowledge could have laid the foundation for later agricultural development. The difference is that the traces of early manipulation would be subtle and hard to detect after glacial cycles reshaped the land. Another pathway toward early civilization comes from understanding how people responded to shared challenges. When sudden cold periods returned, groups would have needed to adapt quickly. Those who had established systems of cooperation, knowledge exchange, and shared responsibility would have been better equipped to survive. If these systems were strong enough, they could persist even when the environment forced people to move again. A civilization doesn't have to leave buildings behind to continue shaping generations. It can leave patterns of behavior, knowledge, and cultural identity that travel with people as they migrate. Considering all of this, it becomes easier to imagine early civilizations developing in the margins left behind by warm ages. These societies may have relied on structures that were not built to last thousands of years. They may have existed in regions now submerged or buried beneath ice. They may have used materials that, under ideal conditions, would preserve well, but under Ice Age conditions disappeared entirely. Their cultural achievements may survive only in indirect forms, such as symbols found on cave walls, pigments in sediment layers, or stories passed down long after the original context faded. The Earth's shifting climate cycles create opportunities for complexity, and then erase the physical evidence of that complexity. This pattern complicates the search for early civilizations because it requires looking in places where traditional archaeological methods struggle. If an early society left its main settlements along now drowned coastlines, or on plains later carved by glaciers, the likelihood of finding clear evidence becomes exceedingly small. Yet the lack of evidence doesn't disprove their existence. It only highlights how much of human history is hidden within landscapes, altered or destroyed by natural processes. Understanding this dynamic changes our interpretation of what early humans could achieve. Instead of imagining progress as a steady climb, it might be more accurate to picture a sequence of rises and collapses tied to environmental shifts. Communities could grow in complexity during warm periods, only to fragment and move when cold returned. Knowledge could survive the transition, but physical remains could not. The world may have seen multiple attempts at building early civilizations long before the ones we recognize in recorded history. Layers of the past don't disappear completely, even when entire landscapes are buried under ice or reshaped by meltwater. They leave small, stubborn clues tucked into places where the cold wasn't thorough enough or where stone proved more resilient than the climate around it. These clues don't arrange themselves neatly, and they certainly don't advertise their significance. Instead, they wait in scattered fragments, microscopic scratches on rocks, unexpected mineral patterns, pigments where none should be, and water channels that hint at activity long before written memory took form. Understanding them means slowing down, looking carefully, and accepting that the simplest explanations aren't always the complete ones. When the ice retreats or when meltwater cuts through frozen ground, pieces of stories rise to the surface in ways that invite questions rather than resolve them. Some of the most intriguing traces come from stone, not because stone preserves human activity perfectly, but because it survives when almost everything else is erased. Rocks keep marks that softer materials would lose immediately. A stone can show where a tool once scraped across it, or where grinding took place. It can hold faint grooves that match repetitive human motions. When these marks appear in layers dated far earlier than expected, researchers pause. The grooves might be natural at first glance, shaped by water or pressure, but natural patterns follow certain rules, and human patterns follow different ones. Water cuts evenly, ice presses downward in consistent directions. Humans leave uneven marks, clustered in ways that reflect the work they were doing. There are locations where stone seems to tell a story that doesn't quite match the accepted timeline. A rock face might show a sequence of parallel lines too deliberate to be formed by flowing water. A slab found under glacial sediment might display wear associated with tool sharpening. In a few cases, small fragments appear with flake scars that look distinctly like the result of intentional shaping. None of these pieces on their own prove anything beyond the fact that early humans were capable of work earlier than assumed. But taken together, these fragments invite a broader interpretation, one that allows for the possibility that organised groups might have achieved more than expected long before the climatic stability of later ages. Meltwater also creates openings into the past. When temperatures rise and ice begins to retreat, water flows through cracks and channels, carrying sediment from deeper layers to the surface. These channels act like temporary windows, revealing pieces of landscapes that haven't seen sunlight in tens of thousands of years. Sometimes the material in meltwater deposits includes small charcoal particles that don't match the natural fire patterns of surrounding ecosystems. In other cases, the sediment holds unusual mixtures of minerals that suggest activity unrelated to the local geology. Meltwater traces aren't easy to interpret because water moves unpredictably, mixing layers and carrying material far from its original location. But even with that uncertainty, certain anomalies stand out, especially when they appear repeatedly across different meltwater sites. One type of clue found in meltwater sediments involves pigments. Natural pigments from soil or rock don't surprise researchers, but there are cases where pigments associated with early human use, such as ochre, appear in layers older than known human settlement. Ochre doesn't form everywhere, and it rarely travels far without human help. When it's found in locations that seem too early or too remote, it raises the possibility that people used it in ways we haven't documented. Pigments cling to stone, clothing, or tools, and even small fragments can survive in sediment for millennia. A single piece of ochre doesn't rewrite history, but the presence of pigment in multiple unexpected layers suggests that symbolic activity, decoration, or tool treatment might have occurred long before typical archaeological evidence begins to appear. Another category of clues emerges from animal remains embedded in old sediment layers. Sometimes these remains show cut marks that don't match the hunting patterns of known predators. The marks appear too sharp, too consistent, or too repetitive to be natural. Early humans were skilled hunters, and they left distinctive signs on the bones they processed. When those signs show up in layers older than expected, they suggest earlier presence or activity. The issue isn't that the marks exist, they undeniably do, but that they appear where human activity is assumed to have been absent. Bone records are particularly sensitive to interpretation because predators and environmental processes can also leave marks. But trained analysts can distinguish between tool use and tooth marks. When repeated examples appear in unexpected layers, the pattern becomes hard to dismiss. Stone circles and unusual alignments sometimes appear beneath glacial deposits. It's tempting to interpret any arrangement of stones as deliberate, but most are accidental. Still, a small fraction displays spacing or placement that doesn't resemble natural scatter. These features might be remnants of temporary shelters, hearth perimeters, or workspaces. Their preservation depends heavily on whether the advancing ice crushed, shifted, or buried them. In rare cases, a layer of sediment settled over the stones before the ice arrived, protecting the shape from complete destruction. When glacial retreat exposes these configurations, researchers must determine whether they result from natural processes or intentional human placement. The difficulty lies in the incompleteness of the evidence. The original context is usually gone, yet the possibility remains that some of these arrangements reflect early attempts to shape the environment for practical or social purposes. Memory also finds its way into the clues left behind, though not in the obvious sense. Human memory transmits through generations, adapting to changing environments, often outlasting physical remains. When stories persist across cultures that had no contact with one another, referencing landscapes that only existed during warm periods or describing patterns consistent with glacial retreat, scholars take notice. These stories don't serve as direct evidence, but they complement the physical traces. Descriptions of retreating ice, vanished lowlands, or great floods appear in traditions around the world. While often metaphorical, their repeated themes might reflect distant memories passed through countless generations. Oral memory may preserve knowledge of landscapes now submerged or buried. When the physical clues and the stories align, even loosely they strengthen each other. Clues frozen in stone extend beyond marks and pigments. Some stones show signs of heating, cracking in patterns typical of exposure to fire. Controlled use of fire is something early humans mastered long ago, but fire-cracked stone appearing in deep, ancient layers prompts questions about the scale and frequency of burning events. Did early groups use fire for warmth, toolmaking, clearing land, or signalling. Fire leaves behind distinctive thermal fractures. When these appear under glacial sediments or within frozen ground layers, they suggest human presence in environments thought too harsh for prolonged occupation. These pieces don't indicate large settlements, but they hint at repeated use of specific locations. Meltwater sometimes exposes wooden fragments or plant fibres that should not have survived. Under normal conditions, organic materials decay quickly, but when buried in cold, waterlogged sediment, they can endure far longer. Occasionally, meltwater channels deliver pieces of wood with cut marks that look deliberate. These finds are extraordinarily rare because wood almost never survives long glacial cycles. When such fragments appear, they require extensive analysis to confirm whether the marks came from human tools or natural processes. Even so, their existence points to the possibility that early groups used wooden structures or tools much earlier than archaeological records currently demonstrate. The cold itself acts as a preservative and a destroyer. Ice protects what lies beneath only if it remains stable. Once it begins to move, the pressure grinds everything in its path. This dual nature makes interpretation difficult. A tool or structure might survive for thousands of years under a stable ice sheet, only to be crushed and dispersed when the glacier shifts. Meltwater might then transport fragments far from their original location. By the time researchers find these fragments, they may have lost all context. The lack of context doesn't erase their value, but it makes reconstruction nearly impossible. The result is a puzzle with many missing pieces and no clear edges. Despite the challenges, some clues remain remarkably intact. Caves along the perimeters of glaciated regions sometimes hold sediments undisturbed by ice. These caves can preserve tools, pigments, and animal remains from early periods. When items appear in deeper layers than expected, or when the cave sediments suggest repeated use over long spans of time, they offer glimpses of activity during periods commonly thought too cold for sustained presence. A cave floor layered with ash and burnt bone might indicate a long-term gathering place. Slight changes in stone arrangement might mark areas used for specific tasks. The consistency of these patterns across layers can reveal the rhythms of early communities. Another intriguing category of evidence comes from plant pollen. Ice and sediment layers trap pollen grains that reflect the environment at the time. Most pollen patterns correspond to natural vegetation cycles, but occasionally researchers find concentrations that imply disturbance or intentional clearing. If certain species appear in unusual quantities, or if pollen from warmth-loving plants appears during colder periods, it suggests environmental manipulation. Early groups might have managed vegetation in subtle ways, perhaps to encourage grazing animals or to create more accessible pathways. This kind of activity leaves faint traces, but with careful analysis, it becomes visible in pollen layers. Even stone distribution in meltwater deposits can hint at human influence. When rocks of specific sizes appear clustered together, especially in shapes not typical of glacial movement, they might represent material gathered for tools or simple structures. Glaciers scatter stones randomly, but humans arrange them according to purpose. Identifying these arrangements requires comparing patterns across multiple sites. Some clusters resemble sorted piles that could have been used for napping, heating, or shelter building. These interpretations remain tentative, but they highlight how even minor differences in stone placement can suggest deliberate action. Memory also appears in cultural continuity. Techniques or materials used by much later groups sometimes resemble those hinted at in earlier layers. This doesn't mean direct inheritance, but it raises the possibility that certain ideas or methods persisted across long periods, even as physical remains were lost. A pigment type used in multiple eras might reflect a long-standing tradition of symbolic expression. A tool shape appearing repeatedly across different regions might suggest widespread knowledge sharing. Taken together, these clues, marks in stone, pigments in sediment, cut patterns on bone, pollen shifts, and meltwater anomalies, form a quiet constellation pointing to early human presence in places where the standard timeline would not expect it. They don't claim a lost civilization outright. They offer something more subtle, hints of organised behaviour, repeated activity, and cultural development long before the first monuments appeared. The cold world of the Ice Age hid far more than it revealed, and its retreat uncovered only fragments. Tools that appear older than the timelines we've grown comfortable with tend to cause a quiet stir long before they reach public attention. In laboratories, workshops, and field camps, researchers examine each piece with careful hands, aware that a single stone flake or shaped edge can upend years of assumptions. The tools themselves rarely look dramatic. Most are small, made from ordinary rock, shaped through repeated pressure or by striking one stone against another. Yet the moment they're lifted from the sediment layer that preserved them, the weight of their implications becomes far heavier than the material they're made of. When a tool appears in a stratum older than the earliest confirmed human presence in that region, it poses a question that refuses to be ignored. Either our understanding of when people were there is incorrect, or the tool is not what it seems. Each possibility opens pathways into a deeper puzzle that continues to grow each time new evidence emerges. One of the first things people misunderstand about ancient tools is how little it takes to confirm intentional shaping. The distinction between natural breakage and deliberate craftsmanship becomes clearer the more closely you look. Flakes from human activity have consistent angles, repeated patterns of force, and specific removal directions. Stones cracked by nature lack those traits. Meltwater, pressure, or frost can fracture rocks. But they don't produce symmetrical edges or patterned removal scars. They don't generate platforms designed for grip or create sequences that show attempts at refinement. When repeated signs of human action appear on objects from layers older than expected, the evidence becomes difficult to attribute to natural causes. Some of the most provocative examples come from areas once believed to be uninhabited during certain early periods. Researchers find shaped flakes far deeper in sediment than the accepted migration timeline allows. These flakes don't belong to the well-documented tool traditions familiar from later eras. Instead, they resemble a transitional or experimental stage, suggesting people were learning, adapting, or experimenting with stone long before the narrow band of human occupation that textbooks tend to emphasize. If these tools are truly as old as their layers indicate, they expand the timeline significantly, implying that pockets of early groups reached new regions earlier than we thought. Dating these finds accurately is one of the greatest challenges. Aeration, soil movement, animal burrowing, water flow, and sediment collapse can shift objects vertically. Even so, in some locations the sediment layers remain undisturbed, thanks to natural shielding or stable soil conditions. When a tool sits within a layer that shows no sign of intrusion, and when that layer is older than the accepted period of human presence, researchers must consider alternatives to the established timeline. They rarely jump to conclusions. Instead, they test again, compare samples, and search for additional pieces that might provide context. A single tool might be an anomaly, but multiple tools from the same time frame begin to suggest an early wave of technological development that predates known cultures. Variation in tool styles also supports the idea of early complexity. Some tools found in deep layers show techniques similar to much later methods, while others show distinctive characteristics that never appear again in the archaeological record. These unique pieces might represent isolated innovations, experiments that did not spread widely, or techniques used by small groups whose traditions were lost to time. When an unfamiliar toolmaking method appears only in ancient layers, it suggests that people were developing region-specific approaches long before uniform traditions took hold. This in turn points to social structures where knowledge passed between generations, even if only within small communities. Stone isn't the only material involved in these mysteries. In a few exceptional cases, bone tools appear in deposits older than expected. Bone, being organic, decays easily, so finding it intact is always surprising. When the bone shows shaping or wear marks consistent with scraping, cutting, or smoothing, it becomes even more significant. These discoveries provide insight into activities that stone tools alone can't reveal. Bone is easier to carve and suited for tasks requiring precision. Its use suggests the presence of knowledge about materials and their properties. If bone tools appear in early layers, they imply a level of technological understanding long before conventional models allow. There are also rare instances where residues remain on ancient stone tools. Plant fibers, animal proteins, or microscopic traces of pigment sometimes cling to their surfaces. These chemical signatures reveal how the tools were used. If they show signs of working wood, preparing hides, or processing plants, they indicate activities that extend beyond basic survival. This expands our picture of early groups into something more nuanced. People weren't only hunting or gathering, they were transforming materials, perhaps building shelters or crafting objects using organic resources that no longer survive. If such tools appear in early layers, they show that humans were capable of sophisticated behavior earlier than assumed. One of the most debated categories of early tools includes pieces found on underwater continental shelves. These shelves were once dry land during lower sea levels, and some areas supported considerable activity. Divers occasionally find stones with unmistakable signs of shaping in places now far from any coastline. When dated to periods well before accepted habitation, these tools suggest coastal groups lived along shorelines that now lie beneath meters of water. Submerged evidence is difficult to analyse because erosion and marine life alter surfaces, yet certain flake patterns and edge modifications remain recognisable. These finds reinforce the idea that large regions once inhabited by early humans are now inaccessible to standard archaeological methods. The mystery deepens when considering how early tools relate to population movement. If people made tools in regions previously thought unoccupied, they must have migrated earlier than believed. Migration requires planning, knowledge of resources, and strategies for survival in varying environments. This suggests cultural development capable of sustaining long-distance journeys. The presence of early tools in unexpected places therefore ties directly to questions about how quickly humans spread across the globe, how they adapted to new climates, and whether they interacted with other groups along the way. Some tools found in older layers show a level of refinement that seems out of place for their age. This doesn't imply advanced civilization in the modern sense, but it does suggest that skilled craftsmanship existed in earlier periods. The individuals who made these tools understood the properties of stone, how to apply pressure to produce a desired shape, and how to correct mistakes. This expertise develops over generations. Tools older than expected indicate that the learning process began sooner and perhaps spread across broader regions than the traditional timeline recognizes. Another category involves tools that simply shouldn't exist according to the dominant models. In a few studies, researchers have found flake scars harvested from stones within geological formations that predate known human species in that area. This doesn't imply the presence of unknown hominins, but prompts a re-evaluation of dates, techniques, and contextual understanding. Sometimes revised dating aligns the evidence with more reasonable assumptions. At other times, the tools remain stubbornly inconsistent with accepted timelines, leaving open the possibility that early human activity extended into periods once thought impossible. Technological development rarely follows a smooth, direct path. It advances in bursts, pauses, regional variations, and forgotten experiments. If early humans created tools during warm periods or stable intervals before glacial cycles erased much of the record, it would explain the occasional appearance of objects that seem temporarily misplaced. These tools could represent moments of innovation that were later overshadowed by environmental collapse or displacement. Later generations might not have inherited the knowledge directly, especially if small, scattered groups disappeared or merged into others with different traditions. The early innovations would vanish from cultural memory, even as physical traces persisted in rare protected sites. Another factor influencing the interpretation of early tools is the absence of associated structures. Without clear evidence of settlements, the tools appear isolated. limiting how much narrative can be built from them. But absence of structures doesn't mean absence of community. Early groups might have lived in shelters made from materials that didn't survive. They might have used caves, riverbanks, or forest edges that later eroded. The tools are the survivors of a much larger pattern of behaviour. When they appear out of place chronologically, they hint at activities that once occurred on landscapes now altered or destroyed. Understanding these mysteries requires patience. Researchers know that one tool doesn't rewrite an entire era. But when multiple tools appear across different sites, each from layers that challenge traditional timelines, the cumulative effect becomes significant. The mystery isn't simply that the tools exist, it's that they appear consistently enough to raise broader questions. These pieces invite a more flexible understanding of early human behaviour, one that acknowledges that people may have advanced, retreated, adapted, or reorganised in ways the surviving evidence can't fully convey. Even today, new discoveries continue to push the timeline of human tool use further back. What once seemed firmly established now looks provisional. The more scientists learn, the more they realise that early humans were capable of adapting to varied environments, developing skills suited to their needs, and innovating when circumstances allowed. The tools older than expected fit into this evolving picture, even if they remain puzzling. They represent moments of ingenuity, persistence, and effort long before the world settled into conditions more suitable for stability. People have been telling stories far longer than they've been building monuments or writing anything down, and those stories often outlast the physical traces of the people who first shared them. Myths tend to survive because they shift with time, reshape themselves around new generations, and hold their meaning even after their original context fades. When these myths describe events that appear older than the societies that preserved them, they open a door to a question that lingers quietly in the background of many fields of study. If a story describes a world that no longer exists, was it created from imagination alone, or could it be a distant memory passed down so many times that the details changed while the core survived? This question becomes especially intriguing when myths from different regions, cultures, and eras echo one another in unexpected ways, hinting that people once carried memories of landscapes and events that predate written history. Many myths refer to worlds lost beneath rising water, or lands swallowed by cold, or cities that vanished after the skies changed. These stories might seem symbolic to modern ears, but they could also reflect memories of real events that occurred long before later civilizations formed. People living through abrupt climate changes, disappearing coastlines, or shifting ice sheets would have experienced transformations that reshaped everything they knew. They might have preserved those experiences in narrative form, turning them into stories so compelling that they survived even when the physical evidence could not. When a myth describes a world that feels unlike anything in recorded history, it prompts us to consider whether it began as a memory of a time much older, one carried quietly through ages of migration and change. Some accounts speak of warm lands that stretched farther than the present coastline, only to be taken by rising seas. Cultures separated by oceans describe floods that arrived unexpectedly, reshaping the world and forcing people to move inland. These flood narratives appear across continents, showing up independently in places that had no contact with one another. There's no single event that explains all these stories, but the end of certain warm periods and the melting of enormous ice sheets did cause global sea levels to rise dramatically. Communities living along ancient coastlines would have witnessed the slow disappearance of their land. Over generations, the creeping loss might have become a story about a great flood or a sudden transformation of the world. When these myths appear across cultures, they suggest that people everywhere were responding to similar environmental shifts, each creating a narrative that made sense of what they saw happening around them. Other traditions describe periods of darkness, extreme cold, or the sudden arrival of ice where there had once been fertile ground. These stories sometimes frame the cold as a punishment or a cosmic event. While the mythological details vary, the core experience of environmental collapse remains consistent. During the Ice Age, climatic shifts were substantial enough to push entire ecosystems into new patterns. If people lived through a dramatic cooling, they might have remembered it not as a scientific observation, but as a tale about a sky that changed, or spirits that withdrew warmth from the land. Over time, these interpretations could merge with other stories, creating complex myths that carried fragments of genuine history embedded within symbolic language. Some myths focus on a time before the current world existed, describing earlier ages when people lived differently, built differently, or understood the world in ways that seem advanced or mysterious. These stories don't provide direct evidence of early civilizations, but they raise the possibility that memories of earlier human activity were preserved long after the physical signs disappeared. A group living near a glacier that later advanced and erased their former settlements would have known that something existed beneath the ice. They might have shared tales about ancestors who once lived on land now unreachable. As the generations passed, those stories could evolve into myths about earlier worlds or ancient eras destroyed by forces beyond human control. In many cultures, there are tales of skilled ancestors who possessed knowledge that was later lost. Some accounts speak of people who could read the behavior of the land, predict seasonal shifts, or build structures that vanished long before the earliest confirmed settlements. These myths aren't necessarily literal descriptions of advanced technology, but they might reflect memories of practices developed during warm intervals when early humans had opportunities to experiment, innovate, or collaborate. When the cold returned and forced people to move, these skills could have faded, leaving only echoes in the stories told by their descendants. The myth then becomes a preserved hint of something real that once existed but no longer has material evidence. A recurring theme in many early narratives is the idea of journeys undertaken across landscapes that no longer exist. Some describe long paths through regions now underwater. Others mention travel across plains that have since become mountain valleys carved by glaciers. These stories might appear fantastical today, yet they could reflect real migrations across terrains that were accessible during lower sea levels. If a group travelled along a coastline that is now submerged, their descendants might preserve the memory as a tale of ancestors who walked across lands that disappeared. Over time, these accounts might blend with symbolic images of lost realms or forgotten pathways. The myth retains the shape of a memory without the details that once anchored it to geography. Myths about people emerging from beneath the earth or disappearing into it could stem from experiences related to caves, shelters, or underground spaces used during harsh climates. When cold advanced, groups might have taken refuge in protected environments. Later generations could transform these memories into stories about origins, transformations, or contact with earlier beings. In this sense, myth becomes a bridge between environmental experiences and cultural identity. The story itself might not be literal, but the underlying memory could reflect how people adapted to dramatic climatic changes. Some traditions speak of groups who lived before the current age, often described as wiser, taller, or more capable. These descriptions don't necessarily point to lost civilizations, but they might reflect how later generations viewed their ancestors. The idea that earlier groups possessed knowledge that was forgotten aligns with patterns seen in communities undergoing environmental disruption. When a population moves from a warm, resource-rich environment into harsher conditions, complex traditions might fade. Knowledge that was once crucial might no longer be necessary. As it disappears, the memory of those who possessed it becomes magnified into myth. Over centuries, this can evolve into stories of an earlier world populated by people whose abilities seem extraordinary. Comparing myths from different regions sometimes reveals surprising similarities. Stories of rising seas, shifting climates, vanishing lands, or earlier ages appear in regions separated by mountains, deserts, and oceans. It's unlikely these shared motifs developed from contact between distant cultures. More plausible is that they emerged independently from shared human experiences of environmental change. The Ice Age and the warm intervals between glacial cycles affected people globally. Even if different groups never met, they lived through similar transformations. These shared experiences might have given rise to narratives with overlapping themes, each interpreting the changes in a cultural framework that made sense to those who lived through them. Myths often encode practical knowledge. A story about a forbidden place might describe a region made dangerous by shifting ice or unstable terrain. A tale about a great flood might warn of rising water levels that once forced people to relocate. A narrative about creatures living beneath frozen ground could preserve memory of large animals that migrated through ice-covered regions. When myths seem to describe events far older than the societies telling them, it's possible that these narratives have travelled through countless generations, carrying kernels of real experience wrapped in symbolic language. Some researchers examining ancient stories propose that myths might preserve information about warm ages now erased from the visible landscape. If people lived along coastlines that later flooded, their descendants might transform those memories into stories about lost lands or sunken realms. These myths might not be literal accounts of early civilizations, but they could reflect real human presence in areas now inaccessible. Over time, the names, events, and specific details would shift, leaving behind only the broad outline of a world that once existed beneath the waves. There are also myths that describe sudden collapses or turning points in human experience. Some speak of periods when the stars changed, when the earth shook, or when the air grew colder. While these descriptions often include supernatural elements, the core event could reflect actual climate shifts. A group living through the onset of a glacial period might experience dramatic environmental changes within a few generations. These changes would be difficult to explain without scientific knowledge, so they might be interpreted as acts of powerful forces or cosmic transformations. As the generations passed, the story would grow but still preserve the memory of the shift. The role of myth in preserving ancient memory becomes clearer when considering how people rely on storytelling. In societies without writing, stories serve as repositories of practical, cultural, and environmental knowledge. They teach survival strategies, maintain group identity, and explain natural phenomena. When people witness events that reshape their world, they are likely to encode those experiences in narrative form. Even after details shift or merge with symbolic elements, the story continues to carry fragments of truth. Those fragments can survive much longer than physical evidence, especially in harsh climates where organic materials decay and ice removes traces of settlement. Some myths are striking not because of their content, but because of their timing. When a narrative describes a world event that aligns loosely with geological or climatic transitions, it raises the possibility that the story might reflect a memory from a time predating familiar civilizations. These connections don't prove anything definitively, but they suggest that myth and science may intersect more often than expected. The challenge lies in interpreting the stories without forcing them into unrealistic frameworks. The goal isn't to claim that every myth describes a real event, but to recognize that some may preserve echoes of experiences far older than written history. Myths also reveal how societies understand loss. When people witness the disappearance of land, animals, or ways of life, they create stories that help them process the change. These stories might describe entire worlds fading, or earlier beings giving way to new ones. If early groups lived through cycles of warming and cooling, their stories could reflect these transitions without explicitly describing the scientific causes. Instead, they might frame the events in terms of cosmic rhythms or moral shifts. Such narratives would persist even after the original meaning became obscure, leaving behind only the impression that the world has passed through several ages, each distinct from the last. By comparing myths with geological and archaeological evidence, a pattern begins to appear. The Earth's layers preserve physical traces of changes that took place long before written language, and human stories may preserve cultural traces of the same transitions. When both sets of evidence point toward the possibility of earlier human activity or forgotten landscapes, they strengthen each other. Myths offer a human perspective on events the Earth recorded in ice, stone, and sediment. Following these threads leads naturally toward questions about how knowledge from earlier ages might have survived, even when the physical evidence was removed by climate shifts, glacial pressure, or rising seas. Knowledge doesn't move through time in a straight line. It shifts, shrinks, adapts, disappears, and reappears in forms that look brand new even when they're not. When we look at the long sweep of human history, it's tempting to imagine a clear sequence where new ideas replace old ones and each generation builds upon the last in a slow upward climb. But the deeper we look into the periods shaped by ice, interrupted by warm intervals, and overturned by catastrophic environmental change, the more it becomes clear that human understanding may have risen and fallen many times before it stabilized into anything we now call civilization. The question of whether knowledge survived the Ice Age or had to begin again after every major climate shift sits quietly between archaeology, anthropology, and the untold experiences of people who lived through those eras. Every scattered clue suggests that the answer may not be simple. Some knowledge likely endured, some was lost entirely. Some may have resurfaced after lying dormant in stories or simple practices passed from one generation to the next. When considering what knowledge could have survived, it's helpful to think about what skills early humans relied on most. Navigation, tracking, shelter building, tool making, fire management, and reading seasonal patterns were not luxuries. They were essential to survival in environments that changed drastically from century to century. These skills would have been taught repeatedly, passed down through sight, repetition, and experience. Even if communities moved or split apart, many of these abilities would remain intact. Children growing up near advancing ice would have learned to interpret small signs in the landscape. Families emerging into newly warm valleys would have learned which plants returned first, which migration routes reopened, and which parts of the terrain became unstable as meltwater carved new paths. These insights didn't require writing or formal education. They were practical, lived knowledge that stayed alive as long as groups remained connected enough to pass it on. But not every type of knowledge is equally resilient. Information tied to specific places can vanish quickly if those places become unrecognizable. A group might learn to survive in a coastal region now lost beneath hundreds of meters of water. They might have understood tidal patterns, fishing techniques suited to that shore, or particular plants that grew only in that microclimate. When the sea rose and the land disappeared, all that tacit environmental understanding would vanish with it. Later generations would move inland and develop new strategies suited to unfamiliar surroundings. Without stable geography, specialized knowledge becomes fragile. The skills that endure are the ones rooted not in fixed landscapes, but in adaptable principles. Fire can be made in many environments. Tools can be shaped from different stones. Shelters can be built using varied materials. But a knowledge system anchored to a specific ecological niche can collapse in a single generation when that niche disappears. Climate instability also influences how knowledge is preserved culturally. During warmer periods, communities might grow larger, stay in one place longer, and develop more intricate social structures. With more stability comes the opportunity to experiment, refine techniques, and accumulate traditions. People could create symbols, art, or long-term storage methods for food. They might develop crafting techniques requiring multiple steps, or systems of cooperation that extend beyond immediate family units. These forms of knowledge depend on continuity and time. If a cold period abruptly returned and forced communities to move, disperse, or shrink, the complexity they had built could fragment. People might remember fragments of an older practice without retaining the sequence of activities required to reproduce it fully. Over generations, a once detailed skill might become a simple story or ritual with unclear origins. Some archaeologists argue that traces of this pattern already exist in the record. There are sudden appearances of tool industries that seem too advanced for their time, followed by periods where simpler tools dominate again. This doesn't necessarily reflect a loss of intelligence, but could reflect a loss of continuity. If a community with sophisticated techniques was displaced, or its population diminished during a cold period, the full tradition might not have survived. Later groups could rediscover some of these techniques independently, creating the illusion of sudden innovation. In this way, knowledge might have survived only partially, resurfacing in simplified forms until circumstances allowed it to flourish again. Oral traditions could also preserve knowledge through extended periods of instability, though not always clearly. A story about a particular plant's healing properties could persist even if the plant became rare or disappeared entirely from the region. The story might remain as a vague reminder, waiting until the environment changed again and the plant reappeared. Likewise, a tale about a dangerous shoreline might continue long after the shore itself vanished beneath rising seas, leaving only symbolic fragments behind. Later generations might reinterpret the myth without understanding that it originally described real geography. This creates the possibility that some knowledge survived in disguised forms, carried through eras when the conditions that originally made it relevant no longer existed. Another question arises when considering the spread of early humans across vast regions. If a small group developed useful knowledge during a warm period, how far could it travel? Migration routes often stretched across continents, and people encountered other groups along the way. They could exchange techniques, materials, or stories during these interactions. If one group learned how to create more efficient tools or manage resources more effectively, that knowledge could spread slowly across generations. But if the group vanished due to environmental collapse or resource scarcity, the knowledge might have halted abruptly, travelling only part way along the migration path before disappearing. This would leave scattered pockets of innovation, some preserved, some lost, with no clear line connecting them. Even simple practices show how complicated this transmission can be. Firemaking, for example, appears to have been known widely among early humans, but the specific methods varied significantly. Some groups struck stones together, others used friction techniques, and still others relied on naturally occurring fire. If a group dependent on a rare type of stone moved into a new environment where that stone wasn't available, they might lose their preferred method and revert to less effective techniques. Over time, they might redevelop different methods or borrow knowledge from neighbouring groups. The result is a pattern where knowledge doesn't rise or fall uniformly. It moves in loops, spreads sideways, or fades until rediscovered accidentally. The Ice Age introduced interruptions severe enough to break many of these loops. Entire regions alternated between being habitable and uninhabitable across long cycles. People had to abandon locations repeatedly. Skills suited to warm, fertile coasts might become useless in frozen plains. Techniques developed for forest-rich valleys might become irrelevant once glaciers covered the land. These shifts could reset cultural development in certain areas, forcing groups to rely on their most basic survival knowledge, while losing much of what they had built during more stable periods. Some researchers believe that certain advanced-looking tools or symbols appearing unexpectedly in later eras might represent fragments of older knowledge rediscovered or remembered imperfectly. A tool with a refined edge could be a distant echo of an earlier technique that was lost and later reinvented. A symbolic marking appearing abruptly might be a reinterpretation of an older practice preserved only in vague stories. In this way, knowledge wouldn't survive intact, but parts of it might linger in cultural memory until conditions allowed them to re-emerge. There's also the possibility that entire bodies of knowledge disappeared completely. Skills tied to specific materials, environmental cues, or seasonal patterns could vanish without leaving any trace. A group capable of building sophisticated shelters from a particular type of wood might lose that knowledge if forced into a treeless region. A coastal community with detailed fishing techniques might lose all such knowledge after several generations inland. Archaeological evidence rarely captures these kinds of losses, because the techniques themselves often leave few durable traces. What we see instead is the absence of certain behaviours, a gap that could represent lost knowledge rather than a lack of capacity. On the other hand, some types of knowledge are remarkably resistant to disappearance. Toolmaking using stone persists across vast spans of time because stone is always available. Navigation based on stars or landscape features remains useful across different environments. Social structures rooted in cooperation, shared responsibilities, and storytelling don't depend on climate. These forms of knowledge endure because they are adaptive. They change shape according to need. Even if specific details are lost, the underlying principles remain intact. Language itself also preserves knowledge indirectly. Certain words, metaphors, or grammatical structures might reflect landscapes that no longer exist. A word for a type of land formation now underwater could survive as a linguistic fossil. A term describing a seasonal pattern might refer to a climate cycle that ended thousands of years ago. Linguistic traces like these hint at continuity that outlasts physical evidence. They suggest that people carried fragments of earlier worlds with them, even as the land changed beneath their feet. Whether knowledge survived intact or was repeatedly reborn also depends on how we define survival. If survival means full preservation, then much was lost. If survival means that certain principles, habits, or conceptual frameworks persisted even as the details faded, then knowledge endured more than we assume. A group that lost its ability to build a particular structure might still retain the basic idea of shelter design. A group that forgot the specific steps of an old ritual might still carry the underlying intention. In this sense, knowledge doesn't vanish entirely. It contracts and expands with the context of each new era. There's also a possibility that early groups achieved brief periods of cultural flourishing during warm ages, only for those developments to collapse under harsher climates. These cycles could have repeated multiple times, leaving behind almost no physical evidence. The people who survived each collapse would have transmitted what they could, but much of their accumulated understanding might have faded. When stability returned, later groups might have redeveloped similar skills independently, creating a pattern where knowledge seems to appear suddenly without clear origins. This would give the impression of innovation beginning anew even when earlier versions existed long before. It's important to recognize that early humans were not passive recipients of environmental forces. They adapted creatively, experimented with new materials, and shared insights through stories, imitation, and practice. Their ability to learn from limited evidence, adjust to unfamiliar terrain, and form social bonds suggests that knowledge could have persisted through even severe disruptions. But persistence does not guarantee completeness. Knowledge might have survived in fragments, woven into practices so ordinary that they appear unremarkable today. A way of binding a tool, preparing a fire, organising a group, or marking a pathway might be the last surviving thread of a tradition that once held far more complexity. Discussions about the distant past rarely unfold in straight lines. They branch, loop, and circle back as new information arrives or old assumptions are reconsidered. Whenever unusual evidence emerges from beneath layers of ice, sediment, or submerged coastlines, the responses often sort themselves into three threads: the careful skepticism of researchers who want to avoid unsupported conclusions, the open curiosity of those who see patterns worth exploring, and the persistent presence of the physical clues themselves, silent but stubborn in their refusal to fit neatly into the frameworks we've built. These three forces, caution, curiosity, and evidence, don't oppose each other outright. Instead, they pull at the same questions from different directions, shaping how we interpret the fragments of human activity that survived the Ice Age. Much of the caution comes from the nature of archaeological work. Every discovery must be scrutinised, every layer dated carefully, every tool examined for signs of natural breakage. Researchers have seen too many examples where soil movement, erosion, or animal activity caused objects to shift, creating misleading impressions of age or context. It's sensible to question anything that appears out of place. especially when the claim it suggests could rewrite major sections of human history. Caution, in this sense, isn't resistance to new ideas, it's a method of protecting the integrity of the work. Without careful evaluation, early interpretations can spiral into assumptions that later require years to correct. When someone encounters a stone flake deep in a layer older than the accepted timeline, the responsible approach is to investigate all other possibilities before considering a revision to our understanding of human presence. At the same time, curiosity fuels the search for deeper truths. Many researchers enter the field precisely because they feel compelled to understand how people lived in environments radically different from the ones we occupy now. They know that the record is incomplete, shaped as much by the accidents of preservation as by the actual events. When an anomaly surfaces, an unexpected tool, a pigment fragment, a footprint in the wrong place, curiosity invites further exploration. It asks whether the accepted timeline is too narrow, or whether the scope of early human behaviour has been underestimated. It reminds researchers that science isn't a fixed set of answers, but an ongoing effort to refine our understanding of the world. Between these two approaches lies the evidence itself, which doesn't offer explanations. It simply exists, waiting to be interpreted. A stone with deliberate flake scars can't tell us who made it. A bone with cut marks can't describe the methods used. A pigment fragment doesn't reveal the hands that mixed it. These clues don't carry agendas or narratives, but they quietly challenge assumptions when they appear in layers older than expected. Evidence in ancient contexts often lacks the surrounding context needed to form definitive conclusions, which is part of why debates persist. When the ice has moved, melted, or crushed the landscape, what remains may be only a fraction of the original story. The tension between caution and curiosity becomes clear when discussing regions now underwater. Many of the world's earliest coastlines lie beneath the sea, submerged after glacial retreats raised global water levels. Underwater archaeology is slow and difficult, and even advanced surveying tools reveal only small sections of the submerged terrain. When a tool or structure appears in these environments, it opens possibilities that challenge the standard timeline. Coastal regions during warm periods were ideal habitats, offering stable conditions that could support growing communities. But caution insists that without clear stratigraphy or preserved context, such finds cannot be placed confidently within a specific era. Curiosity, on the other hand, notes how these submerged landscapes align with gaps in known evidence, suggesting that early activity might be missing from the record simply because the locations where it occurred are now inaccessible. Another area where the debate intensifies involves early climate transitions. Ice cores, sediment layers, and pollen records show abrupt shifts that changed ecosystems dramatically within short spans of time. People living through those shifts would have responded in ways that don't always leave durable traces. They may have moved quickly, reorganized their communities, or abandoned certain areas. These rapid changes could erase long-standing traditions or spread groups thin enough that cultural continuity fractured. When researchers see abrupt cultural changes in the archaeological record, caution advises them to attribute these shifts to migration or population replacement. Curiosity suggests that climate disruptions may have played a more complex role, perhaps wiping out early advancements or scattering communities whose innovations never became widespread. The debate grows more intricate when considering symbolic behaviour. Archaeological sites from well-dated periods show clear evidence of symbolic expression. Carving, painting, body decoration, and rituals that reflect abstract thought. But sometimes similar pigments or symbolic markings appear in older layers, albeit in fragmentary or ambiguous forms. A cautious interpretation suggests they might be natural pigments displaced by soil movement. A more curious perspective wonders whether they hint at an earlier wave of symbolic behaviour now lost to time. The evidence itself doesn't resolve the debate. It only shows that something unusual is present, something requiring interpretation. Within the scientific community, these debates often hinge on definitions. What counts as evidence of human presence? What degree of modification qualifies a stone as a tool? How much weight should be given to indirect signals such as soot concentrations or unusual mineral patterns? Definitions shape interpretations, and interpretations shape conclusions. Caution strives to maintain clear standards that prevent overreach. Curiosity pushes those standards gently when multiple anomalies accumulate. The evidence lies between them, silent but persistent, encouraging refinement of the questions asked rather than delivering straightforward answers. In some cases, caution leads researchers to re-examine long-held assumptions about human migration. For many years, the timing of early migrations into certain continents was limited by the oldest, confirmed tools and settlements. When earlier footprints or tools began appearing in deeper layers, caution dictated verifying the context, checking for soil disturbance, and testing dating methods repeatedly. Even after such steps, debates persisted because the implications were significant. If people arrived earlier than once believed, it would reshape models of human dispersal. Curiosity embraced this shift, noting how the new evidence matched predictions made by researchers studying ancient climate maps, food availability, and migration corridors. The evidence ultimately brought both sides toward gradual revision, showing how debates can converge when additional data accumulates. Another dimension to this ongoing tension emerges in discussions about potential lost knowledge. Caution insists that without direct evidence, structures, artifacts, written records, we cannot claim that early groups reached levels of complexity comparable to later civilizations. Curiosity points out that physical remains from those periods would be exceedingly difficult to preserve due to glacial cycles, rising seas, and the fragility of organic materials. Evidence in this field tends to be indirect, composed of small fragments such as tool variability, pigment residues, or patterns in animal remains. Each fragment may be modest on its own, but together they suggest possibilities that the archaeological record hasn't fully revealed. The interplay of these forces becomes especially clear when examining claims made outside academic circles. Some interpretations stretch thin evidence into elaborate theories. Caution reacts to this by tightening standards, insisting that extraordinary claims require extraordinary proof. Curiosity remains open to the idea that early humans may have achieved more than we know, but it resists speculation unsupported by material traces. Evidence itself remains unchanged, but debates about interpretation intensify. Researchers must balance the need for scientific rigor with the willingness to follow leads that don't fit existing frameworks. Too much skepticism may prevent valuable insights, while too much openness can lead to unfounded conclusions. As data collection improves, debates shift. Advanced imaging tools reveal hidden layers beneath ice. Underwater scanning identifies possible settlement patterns on submerged plains. Chemical analysis uncovers unexpected compounds in ancient sediments. Each new method adds pieces to the puzzle while also raising new questions. Caution ensures that these methods are validated and understood properly. Curiosity drives new approaches, pushing technology into areas previously thought inaccessible. Evidence grows not only in quantity but in diversity, offering multiple angles from which to interpret ancient behaviour. There are moments when caution and curiosity align closely. This happens when evidence becomes overwhelming enough to support cautious acceptance of new interpretations, while still leaving room for deeper exploration. The discovery of early artwork, for example, required decades of debate before being fully acknowledged. Initial skepticism gave way as more examples appeared, each supporting the idea that symbolic behaviour emerged earlier than previously believed. This pattern repeats across many fields. What begins as an anomaly eventually becomes accepted once enough evidence accumulates. In discussions about possible early civilizations, the debate remains far from settled. Caution emphasizes that civilization requires specific markers, architecture, agriculture, long-term settlements that haven't been found in early layers. Curiosity counters that the environments in which early humans lived were unlikely to preserve such markers even if they existed. Evidence, meanwhile, hints through subtle traces, organised hunting strategies, long-term site use, expansions of tool complexity, and patterns of resource management that mirror later forms of structured behaviour. These hints don't prove anything conclusively, but they complicate attempts to dismiss the idea outright. The most difficult part of navigating these debates is accepting uncertainty. The Ice Age reshaped landscapes so drastically that vast stretches of human activity may have been erased completely. With so much missing, interpretations must lean heavily on what little does remain. Caution urges restraint. Curiosity invites thoughtful hypothesis. Evidence lies between them as both anchor and catalyst. When researchers strike the right balance, debates become productive rather than polarizing. They encourage new investigations, refine dating methods, and broaden our understanding of what early humans were capable of. Similarly, the debate extends into how we understand memory, both cultural and geological. Ice cores, fossil pollen, and sediment layers record environmental changes, but interpreting those records requires both skepticism and imagination. Myths and oral traditions preserve echoes of experiences that may bridge deep time, but interpreting them requires care. Evidence suggests connections. Caution demands verification. Curiosity explores the potential meaning of those connections. The landscape between these viewpoints is where insights begin to form. If the history of our species is not the first long narrative that Earth has carried through changing climates, shifting coastlines, and the advance and retreat of ice, then the way we think about the past, and even the way we think about ourselves, changes in subtle but meaningful ways. It doesn't require imagining elaborate lost empires or technology far beyond anything supported by evidence. It simply means accepting that human experience may not follow a single, rising curve from simple beginnings to complex societies. Instead, it may have unfolded in cycles shaped by climate, geography, and the fragile continuity of memory. If other groups at other times reached moments of organisation, cooperation, or cultural depth before those traces were erased, the story we tell about the human journey becomes both wider and more layered. Rather than one long upward path, it becomes a series of attempts, adaptations, and rediscoveries carried across ages separated by ice and silence. Contemplating this possibility doesn't diminish what later civilizations achieved. It instead adds weight to the resilience shown by early communities navigating landscapes more volatile than anything familiar today. If people organized themselves socially or technologically during warm intervals long before the stability of the Holocene, it means the roots of cooperation and ingenuity reach deeper into time than archaeology can easily document. When we picture these early groups, it's easy to imagine them as scattered, isolated, and focused solely on survival. Yet the clues found in stone flakes, pigments, bone markings, and footprints suggest something more dynamic. People were not only surviving but observing, experimenting, and sharing what they learned. They were noticing patterns in seasons, understanding the behaviour of animals, adapting tools to new materials, and forming bonds strong enough to carry traditions across generations. If this happened in more than one era, during multiple warm periods separated by long stretches of cold, then human complexity might have risen and fallen many times before stabilizing into what we now recognize as civilization. These earlier attempts would leave only faint traces because the environments in which they occurred were later reshaped so thoroughly that nearly all physical evidence vanished. Coastlines disappeared, valleys flooded, plains rose and fell with glacial pressure, forests that might once have held long-term settlements were buried or scraped clean. If people lived and flourished in those places, their worlds would be nearly invisible to us now, leaving behind only scattered hints that something once transpired where the landscape no longer reflects their presence. The possibility that Earth holds earlier stories transforms the way we view absence in the archaeological record. Instead of assuming that no evidence means no activity, we begin to recognize how incomplete the surviving record truly is. What remains preserved today is shaped more by chance than by the scope of past human experience. A community that built structures from wood or earth might leave nothing behind after thousands of years of climate shifts. A tool tradition practiced for generations could vanish if the material used was fragile or if its traces lay in a region later submerged. A symbolic practice could be entirely lost if expressed through pigments or textiles that decayed quickly. When we realize how much depends on luck and circumstance, it becomes easier to imagine that many human stories unfolded in the spaces erased by ice and time. This perspective also reframes how we understand innovation. Rather than imagining that complexity emerged suddenly in a few key regions, we can see innovation as a natural human impulse arising wherever conditions allow. If early groups experimented with new tools, cooperative strategies, or symbolic expression during past warm periods, then innovation might have been cyclical rather than linear. Each cycle could begin with small communities adapting effectively to stable environments. Over time, these adaptations could accumulate into more organized behaviors. But when the climate shifted again and stability vanished, much of that accumulated understanding could fade. Later groups might reinvent similar practices when conditions once again favored growth, giving the impression of sudden leaps rather than long-hidden patterns of development. Understanding that we might not be the first story the Earth has told also shifts how we interpret myths, symbols, and cultural memories. Many traditions speak of earlier ages, forgotten worlds, floods, and lands that vanished. While these stories are not literal accounts, they often contain echoes of real environmental shifts. If a group preserved memories of a warm age that ended abruptly, or a coastline that slipped beneath rising waters, those memories could transform into myths about previous worlds or lost realms. Over thousands of years, the details would blur, but the core themes could remain. These themes might then reappear in cultures far removed from the original events, suggesting shared human responses to disruptions that occurred repeatedly across different eras. If earlier chapters in the human journey existed and were erased, it invites a reconsideration of what counts as progress. Instead of seeing civilization as the inevitable outcome of human development, we begin seeing it as one of many possibilities that emerged under specific environmental conditions. The stability of the last 10,000 years allowed agriculture, cities, writing, and long-term institutions to form, but earlier groups living in less stable climates may have reached different forms of complexity, ones suited to their surroundings, ones that did not leave lasting architecture or durable artifacts. Their accomplishments would be measured not in monuments, but in survival strategies, cultural expression, and knowledge adapted to landscapes that no longer exist. This view highlights the adaptability of humans rather than the inevitability of civilization. It emphasizes how quickly people can reorganize themselves when conditions change, and how creatively they respond to new challenges. If people survived multiple cycles of climate instability, they likely carried fragments of knowledge across those transitions. Even if large systems collapsed, essential principles may have persisted: cooperation, tool-making, storytelling, and the ability to read environmental cues. These principles form the foundation of human culture, and their continuity suggests that even if earlier attempts at complexity were lost, they contributed indirectly to later developments by shaping the resilience and ingenuity of those who survived. At the same time, accepting the possibility of earlier stories means accepting that most of what once happened will never be recovered. The Earth is not a perfect archive. It keeps only a fraction of what it witnesses, and it erases far more than it preserves. The portions that survive do so because they happen to fall in places where conditions favoured longevity: dry caves, underwater silt beds, or stable sediments untouched by glacial movement. Most human activity occurred in landscapes that were later transformed in ways that destroyed delicate traces. If people built shelters in forests, lived along ancient coasts, or travelled across plains now hidden beneath oceans, their presence might only be detectable through indirect signals. These signals, tool fragments, pigment traces, unusual sediment layers, are subtle reminders rather than clear evidence. They whisper rather than speak, offering glimpses rather than full accounts. Thinking in these terms encourages humility. Our view of the past is shaped not by the sum of all that happened, but by the sum of what happened to survive. When we assume we are the first story the Earth has told, we risk overlooking how much was lost before our earliest records began. Recognizing that there may have been other stories doesn't change our place in the world, but it enriches the context in which we understand ourselves. We become part of a larger tapestry of adaptation, resilience, and curiosity, a tapestry woven through multiple cycles of change. This perspective also opens space for questions rather than conclusions. Instead of seeking definitive proof of early civilizations or dismissing their possibility outright, we consider how evidence, memory, and environment intertwine. We see how small hints in the geological or archaeological record can suggest larger patterns without fully revealing them. We recognize that ancient people may have known more than we assume, not because they possessed advanced technology, but because they were deeply attuned to their surroundings in ways that modern life often obscures. If we are not the first story Earth has told, then the significance lies not in the specifics of the lost chapters, but in the continuity of human experience. Every group that adapted, learned, and persisted contributed to the long arc that eventually led to the present. Their stories, even if erased materially, may echo in the practices, instincts, and shared memories that later generations carried unknowingly. The land remembers in its layers. People remember in their stories. Between the two, fragments of earlier worlds survive,